Power. Most people would envision some sort of big, bulky bodybuilder, or even the energy that supplies your phone's battery. However, for statistics, power is a lot more technical than that, and believe it or not, it can be used to determine what to make out of your test of inference. I'm Daniel Chung, and this is Statistics. When you make a test of significance, you start with a null hypothesis, a proposed value of parameters or difference of parameters, and an alternate hypothesis, a collection of possible parameter values competing with the null hypothesis. Really, you're only interested in power when the null hypothesis is false. Now, what is power? Power is the probability of correctly rejecting the null hypothesis. It's a conditional probability because the null hypothesis makes a statement about parameter values, and the power of the test is conditional upon what the value of those really are. To understand this, we'll use this tree diagram to figure out reality from conclusion. You see that alpha is the probability of a type 1 error, and beta is the probability of a type 2 error. Also, power is 1 minus beta, or the probability of a correct decision given the actual parameter value. There are other ways to explain power too. It's the probability that a test of significance will pick up on an effect that is present, or a deviation from the null hypothesis. Or it's the probability of avoiding a type 2 error. So what is power? There are 4 things that affect power: alpha level, sample size, the inherent variability in the measured response variable, and the difference between the hypothesized value of a parameter and its true value. As we mentioned before, alpha is the probability of a type 1 error. So the larger alpha gets, the larger rejection region there will be. So if alpha increases, power also increases. The same goes for sample size. As n increases, so does the power, because a larger sample size narrows the distribution of a test statistic, so it becomes easier to tell one distribution from another. However, in real life terms, this is not exactly plausible because it takes more time and resources in order to collect more data. For variability, however, there's an inverse relationship. As variability increases, power decreases. Researchers have trouble correcting this problem because you can't completely control the variability in the response variable, but it can be reduced. A matched pairs design compared to a completely randomized design usually reduces unexplained variability by taking out the extraneous variables that individual subjects bring to a study. The difference between the hypothesized value of a parameter and its true value is called the magnitude of the effect. The larger the effect, the more powerful the test is. For example, let's say that a null hypothesis states that the mean height of LQ girls is 6 feet, and then we're given 2 samples that suggest the null hypothesis is false. One sample gives a mean of 5'6", while the other gives a mean of 5 foot. Both have the ability to reject HO. However, the sample with a mean of 5 feet will be more powerful than the other sample because the gap between the null hypothesis and the test statistic is much greater. Therefore, all the factors which cause us to reject HO, it's less likely that that's due to chance alone. If you're concerned about needing to calculate the statistical computation, maybe it'll help you know that the AP Statistics curriculum does not expect students to know that at all. However, you should understand what power means and what affects the power of a test. I'm Daniel Chung, and good luck, Stats Nation.
We don't see the sink. You want to come hang out with us? No, put it this way.
This way?
This way.
I put my hair this way.
No, put it this way, and then I'll put it back out the other way.
But
Put it down. Put it down. Put it down. And now switch it over to the side.
But not a lot.
You gotta fluff it. Fluff your hair. There, stop! Good.
The difference between the hypothesized...
Hypothesized.
The difference between the hypothesized...
You didn't have a list before today. Just be more calm.
Okay. The difference between the hypothesized...
Daniel.
I'm Daniel Chung, and good luck, Stats Nation.
That was a creepy wink. The way you did it. The way you did it. No, but